Okay, folks. So welcome to this introduction session about OpsWorks. This is Reza. I'm Jonathan. We're both from the OpsWorks team. And we want to give you an introduction to the underlying concepts of OpsWorks, into how to customize it, and how to what the differences are between Chef Server and other technologies people use. Before I go into details, how many people have used OpsWorks? Okay. And of the others, like, do you have a rough understanding how it looks like? Who has an understanding how roughly OpsWorks works, what it should be? Great, so that I don't have to do too much of an introduction. So what we want to look into is, I want to explain to you the OpsWorks lifecycle system, which is a very important part of OpsWorks. To understand that gives you really the power to make use of OpsWorks. Then Reza is going to show you how you can customize OpsWorks, how you can run, for example, MongoDB as a custom layer on OpsWorks with a setup with Java and ELBs, and how to leverage technologies that AWS doesn't support out of the box, but you can, by bringing your own cookbooks and chef recipes, you can basically, anything that is scriptable, you can make run on OpsWorks. And then we're going to close with a kind of comparison between Chef Server and OpsWorks. This is a question we get a lot. What is the differences? How do I migrate? Like, what do I have to take care of if I have Chef Server in use and I want to use OpsWorks? And we want to like make clear what the differences are and where it's the same and where it differs a little bit. So let's dig into the lifecycle system. Like I said, that's very important to understand that, because that gives you the possibility to really exploit all the features that OpsWorks gives you. The heart of OpsWorks is our agent. So in order for us to be able to execute commands on your behalf, like to do deployments, to install software on your instance, we have to be present on it. And that's a big difference to other services that don't have anything running on your instance. So OpsWorks has an agent running that communicates back to the OpsWorks backend over an encrypted and secure connection, and executes commands that, that you tell it to do, like bootstrap my machine or do a deployment and so on. That execution of commands is just a Chef solo run. So if you're familiar with Chef, we just use the OpenChef solo version there. You can choose if you want to use Chef 09 or Chef 11, and we will keep up with future Chef releases so that we will provide you like a Chef solo environment. What are those events that OpsWorks provides? We offer 5 lifecycle events that you can hook into and extend with your own recipes. The first one is setup, like the initialization of the instance. Then we have configure, which is like an event that you can respond with your recipes to changes in the system. Then there is a deployment, which means you are pushing actively new versions of your app to the machines. We have the undeploy, which means you want to remove an application from running machines. And then there is the shutdown, which offers the possibility for you to do a clean shutdown of machines. Like before we terminate it on EC2, you can like clear resources, flush anything from memory to disk, and so on. So we're going to look into those in depth in a moment. Before we do that, I want to briefly like explain to you what are the different stages of an instance. Like what kind of states can it have, and when do we fire those events? So if you have a new instance, we start fresh. We start like what in OpsWorks we call the new state. It doesn't even exist on EC2 yet. It's just you told us, I want to have an instance. It should be of that type. It should exist in that AZ. It should be that operating system. I want to use this specification for it. At some point, you're telling us we should start it, which means the instance will run through the states of requested, pending, booting. At that point, the booting state means it's fully running on EC2. So it's fully active now. And the next stage will be the agent part installs itself and calls back home, basically, and requests this initialization. So it should now become your Rails application server, your Java app server, whatever you told us it to be. So what happens now is the setup event fires. The machine will run it. And when it's ready with that setup and it's successfully completed the setup, we will consider this instance online, and it will be available for other instances to use. And the very important thing is, and why we call that a continuous configuration or continuous lifecycle system, is that at that point in time, we fire a configure event to all machines in your stack. So other instances can respond to this change and now know, oh, there is a new app server available. I, as a load balancer, can now serve traffic to it. Or if your new app server turns out, you can, your database server can now add an ACL entry in order for this instance to allow it to connect to it. So that configure event is like the stage where you would make sure that your view of the stack is still the correct one. And you can listen to nodes coming, and you can, the same thing that you can do, you can do listen when nodes are leaving the system. Probably the majority of the time, the instance will be in that online state. And what you can do now is continuously deploy to it. So you can like deploy a new version of your app as often as you like. And this is when we will fire that deployment event. At some point, you probably want to shut it down or replace the instance by a different one. So you start terminating that machine. This will fire the configure event again to every other nodes in the stack. So they know this server is no longer a part of the stack. A load balancer can remove it from the configuration. The database server in our example can now remove the ACL entry so that that IP is no longer allowed to connect. If you use kind of distributed databases, you could now say, OK, we shouldn't now try to chat with that machine, for example. And also, like I mentioned in the beginning, that we would not shut down the instance immediately. So your instance now has some time to do a clean shutdown before we actually shut it down on EC2. Once we shut it down on EC2, you're back into that new stopped state where if you had an instance store instance, it's actually gone on EC2, just the model exists with us. If you have an EBS-based or EBS-backed instance, it's of course still exists on EC2, and you can restart it, and it will be the same instance on EC2. And to understand that kind of lifecycle is pretty important in order to know on which lifecycle event should I like run which recipes. And it allows you to do like a kind of a dynamic configuration management. So whenever something changes in your state, like a new server is showing up, that event bubbles through to all the others, and they can respond to it and adopt their configuration dynamically. Let's briefly revisit the individual events so that we know when to use them and what they are exactly. So first, we have the setup event. This is sent whenever an instance first boots, and you can use that in order to pre-configure the machine, run any bootstrapping. Usually, you install your software that you want to permanently running on that machine at that stage. So let's say you want to have a Java JBoss application server. This is the time when you would run your recipes to install the JDK, to install JBoss, to make sure everything that you need on the machine is present. That event only fires once in the lifetime of a machine. So usually, you do that for that first initialization. One important thing to hint out is that this initial setup includes the deploy event. The reason is that probably when you boot a new app server, you want it to be ready, right? And ready means it should be deployed. It should have all my software on it. And that's why we include the deploy event, which means that if you look at the actual recipe order, what is going to be executed, it looks like this. We will first fire our built-in setup recipes. We will then run your setup recipes that you told us to run. We will then run our own deployment recipes, and then we will run yours. That is something that usually unfortunately we don't explain this good enough in our UI. We're going to improve that in order to make it more clear. But this allows you to hook both into the setup state and into the deployment state if you want to do any customization. We're going to talk in a minute about how you do that customization. The next event is the configure event, and that fires whenever an instance either enters or leaves the online state. So usually you would use that to respond, to make sure your configuration is up to date, to like, do I need to know how many nodes there are, what the IP addresses are? If so, I would do whatever needs to change during that step. The simplest example is your app server needs to know where the database server is. So you would add a recipe that checks, that regenerates your database config file that the app server is using during a configure step. For example, our built-in Rails layer and PHP layer and Node.js layer, this is what they're doing during that step. They just regenerate for Rails the database YAML file. For PHP, we have a simple PHP library that we regenerate so that all the app servers always know what is the correct IP address of my database server. So when you like shut down your database server and replace it with a different machine, like magically the new IP shows up in that file because the app servers regenerate the file whenever a server comes and goes. Should the server actually not be a database server, nothing happens. That file stays the same, so like your app servers don't restart themselves, for example. if the file ever changes, in the example for Rails, like Apache will restart the Rails app so that the change will actually be effective to your app. The other thing is the deployment that happens when you explicitly deploy your app, either via the UI, CLI, or APIs. Also part of setup, like we said. But you can fire that at any time you like. Like whenever you say, oh, I have a new version of my app, I want to now make all my nodes aware of it, you would fire the deploy event, and that will tell the nodes to please re-download the app from this is the location where I told you it's going to be, or do whatever like your custom deployment needs to do. This is also the place if you're not happy with the built-in deployment mechanisms we provide, you would use that for custom hooks. So for example, if you use rsync for deployment, that's fine, works with us. You just have to provide your own recipes to do it. However you would like to deploy, you can do it here with your own recipes. The undeploy event is probably the least used. That happens when you delete an app, but you still have running app servers that have it. In this case, you can then remove it from the app and restart your app server. A use case would be, let's say you host a large number of PHP apps as different vhosts on the same fleet of app servers. And if one of your customers terminates the service with you, you want to like delete the vhost from your machines. You would do that in that step, for example. And the last one is the shutdown event that allows you to run any scripts that you need in order to cleanly shut down a machine before it's actually taken out and terminated on EC2. So a good example is you run some in-memory database, and you need to make sure it's flushed to disk before you actually terminate the machine. You have about 45 seconds to do that action. Afterwards, we'll like force terminate the machine. So if you have something that, so you need to make sure that you stay within that limit. Otherwise, we cannot guarantee that the action will actually complete. Now that we understand, okay, what are the different life cycles, where can I hook in? Let's look at how can you now customize OpsWorks. Like if I am not happy with the built-in defaults, what means do I have to like customize it and use a software that OpsWorks doesn't support out of the box? In general, we have like different ways to do it, and they reach from very simple, but that means you also cannot do too much, to you have a lot more control, but they're probably a lot more complicated. You have to provide a lot more code. So the simplest one is you just use our built-in layers, which actually means no big customization apart from what you can do in the UI. Then you can like influence how we render templates, how we configure the machines via chef attributes. You can use that in using custom JSON. You can do that via custom cookbooks. The next step would be you overwrite complete template files, which means that you change how we render like the Apache vhost configuration or the MySQL configuration on disk. But you still don't have your own chef recipe. You just have a template file. Providing a chef recipe is a very big step for most people, because they have to write a chef recipe. That's why Chef also supports something called deploy hooks, which is something that you can provide within your app without having a separate repository for your chef cookbooks. And we're going to look into what you can do with that. And the real full-blown solution is to use all the capabilities that Chef offers, which means you can either provide a custom cookbook or custom recipes to extend our built-in layers, or you can just create your fully customized own layers. Don't use the stuff that we provide. Just start with a blank machine and say, okay, those are the scripts I want to run. I don't care that Amazon offers a Rails app server. I need to configure totally differently. This is how I do it. And we're totally happy with that. The important thing to remember from that talk in that sense is that OpsWorks is that lifecycle system that we fire the right event at the right time to the right instance of part of the right layer. It just happens that we've wrote a couple of chef recipes for common stacks, for common technologies. If you want to customize more, if you're not happy with those, feel free to bring your own. Feel free to use whatever you like. The power of OpsWorks is really that lifecycle system, the integration with EC2, the deployment support, the management and monitoring support. The existing chef recipes just get you started. So let's dig into each of those things, like how would you use it. The built-in layers are probably the simplest one. So we have 8 built-in layers ranging from Rails, PHP, Node.js, Java to MySQL, HAProxy, Memcached, and Ganglia. All the recipes that we use are open source on GitHub, so you can look at them. Actually, in our UI, we also link to them if you're interested. So you can feel free to look at them and how to implement them. Feel free to submit pull requests if you think they could be improved. And they offer you kind of a convenient way to get started. Like we try to make them pretty general, but usually at some point, especially the more complex your app gets, at some point you're maybe not happy, you want to influence it, and you want to customize it. The simplest way how you can do it is by using attributes. And before we look at attributes, we need to revisit how a chef template looks like. This is a typical chef template. In this case, a part of the template we use to render the Apache configuration. So a template that is well written usually doesn't hard-code values. It refers to them what is called in Chef an attribute. You can think of it as a variable, basically. So our example is the timeout. So here we define the timeout not just a hard-coded value, but we say the timeout should be whatever is in Node Apache timeout. And by doing this, you're not tying your templates to a specific configuration. So you can make this value dynamic. You can override it, how we're going to see in a second. And hopefully, most of our templates are configurable this way. Because if they are, what you now can do is you can change this value if you're not happy with our default. Our default is written in the chef attributes file. So in this case, in the Apache 2 cookbook, there is an attribute file, and somewhere it says default Apache timeout equals 120 seconds. If you're not happy with that value and you want to change it because you want to have lower values or higher values, what you can do is utilize custom JSON. So in OpsWorks, you can add arbitrary JSON to each stack. And this JSON will actually end up in the chef run available as a node attribute. So in this case, I'm just setting, like underneath that box, you see the custom JSON that I'm setting. So I'm setting Apache 2 and then timeout to 60. So what happens when chef actually runs is that lookup value, so node Apache timeout, will be 60 and not 120. Which means when chef renders the template, the result will be a timeout of 60 instead of our default of 120. By doing this, using custom JSON, you don't have to provide a custom chef recipe. You don't have to provide your own repository of chef cookbooks. You just have to enter a JSON field in our UI. Doing that for maybe 1 or 2 values is OK, but probably at some point you realize maintaining a large JSON structure in a text field or via the API is not the best way to do it. And probably you want to version control that. You want to have like more control about that. And the next stage, how you could do it, which we recommend, especially if you do more than 1 or 2 values, is to use just a custom attribute file where you override the value. In order to be able to do that, you need to provide us with a repository of your cookbooks. So you need to have either like accessible via Git, SVN, HTTP, or some zip file on S3 that your instances can reach that have your own chef recipes and cookbooks. In this case, you need to have some attribute file that defines or overrides this value. In this case, you use set Apache timeout to 60. The result will be the same. So when you render the template, it will have the value 60 in it instead of the value of 120. This way, you can, again, like change the templates and the values that we provide. Probably at some point you're not happy with or this way of customizing is limited to our templates and limited to the places where we provide you with an attribute lookup value. Maybe at some point you say, okay, I want to have the Apache config file looking totally separate, totally different, or maybe this value is not configurable, or I need to change so many things that it would be just unmanageable doing that with attributes. So the next step that you could do is override the complete template. So in this case, you just provide us in your own custom cookbooks with the same file under the same location as the template you want to override. So in this case, you would have in your custom recipe cookbooks, you would have Apache 2 templates. There's actually a default missing, I'm just see. And then Apache 2 conf.erb, which is the same path as the original template that we used to render this file. And in this case, the content can be arbitrary. Whatever you put in that content will end up on the machine when Chef renders the file. You can, of course, reference attributes in there. You can have hard-coded values. Whatever you have in it, Chef will take that and render it instead of ours. That gives you the possibility to really influence templates, but you're still very much tied to our recipes, and you're still very much tied to how we do things. If we don't have a template for something, you can't do it. Unfortunately, with Chef, you cannot override recipes. But what you can do, you can provide us with additional recipes. So the next step is you do that either by providing a full-blown recipe, or if you only want to do something within the deployment of an app, you can actually also use deploy hooks. Deploy hooks are provided by the Chef deploy resource that we use by default. And there are 4 available. They're called before migrate, before symlink, before restart, and after restart. And you can basically do, again, anything in them, and they will be run within the context of deployment of one application. The important difference to full-blown recipes is that they will be run within the actual deployment process of your app. So you can like influence, before we restart Apache for you, you can do something. Or before, if you use Rails and do database migrations, before the migrations are run, you can do something. In this case, the only thing you need to do is provide a directory called deploy in your application and have those files in it, one of them or all of them, depending on what you need. The file itself uses the Capistrano syntax. It's like influenced by it, which or used to be a very popular deployment tool from the Ruby world. The syntax looks like this. So this is an example how you would do, for example, for Rails, asset precompile compilation of your CSS and JavaScript. So if you use like Rails 3 or 4, what you usually do is you have your JavaScript in CoffeeScript, and you need to compile it before you actually can use it in production. So one way to do it, you would compile it before you actually deploy to us. But that means you have to check it out into source control, or you have to put it in the zip file you deploy. Another way to do it is you do it on the box before you're actually ready with the deployment. So this is one way to do it. In this case, you execute the rake command in order to do that compilation, and then we restart some random service. Just to show you that you can use either run commands as a deploy user, or you can use sudo and then run things as root. This way you can again, you can easily influence the deployment path, but you don't have access to full-blown Chef in here. If you want to use full-blown Chef, what you need to do is use custom cookbooks. The first step would probably be you manipulate our built-in layers. So in this case, we added to the setup event, for example, of the database, so we added a recipe called backup run that we will execute as part of the setup. And you have to provide the sources for that. So you would give us a repository of Chef cookbooks, and Chef would find the backup run recipe in it and would execute it. And whatever it's doing, that's what will end up on the box. So that gives you the possibility, in this case, probably like you want to do an hourly backup of your MySQL server, or of your MongoDB server, whatever you do. The most extreme case of customization is you create custom layers. So you don't use what we provide. You just say, I want to use a custom blank layer, and I do whatever I need to do. So we have customers running, for example, Erlang, Cassandra on it, or you have some custom CDaemon that needs to be installed and run, or you're not happy with the way we install PHP, and you want to use the latest and greatest and install that. So for all of those things, you can do just by using a custom layer and creating that. How it would look like is you basically add a layer, you choose custom as the type. In this case, we're going to deploy an Erlang app, so I'm giving it the name of Erlang app server. The short name is how it will be identified within a Chef run so that you can look it up from other instances. And then I add some recipes to it. So I install Erlang, and I need a recipe for deploying my app. This is an example how like the recipes could look like. So I could have an Erlang cookbook where I have a recipe to install Erlang and to uninstall it. And I have then a cookbook to deploy my Erlang application, where I need to in this case, I implement deploy and undeploy, and probably I will also implement configure in order to like tell it where are the resources, where are the other instances that I care about. We're going to look later into detail how you could do that as an example with Java and MongoDB. So we're going to see a little bit more how you can do that. And then I can just happily add servers to my custom layer. So in this case, I have 2 Erlang app servers. And this is how I make sure that I actually run Erlang on OpsWorks. Another question that we often get is, what if I don't like Chef and I want to do some other way of customization? Or what if I already have a bunch of Chef bash scripts that I used in the past to initialize my servers, and can I use that? Today, we only support Chef, but what you could do is you can easily have a simple Chef recipe that just calls out to your existing initialization scripts, or that starts a Puppet run, for example, just passes all the metadata that we provide to Puppet. So this is a very simple example of how to call bash from Chef recipe, in this case to run some random installer and do the typical make install dance. So you can easily, if you have some form of legacy or some form of existing scripts that you don't want it to have to convert to Chef, you can easily do that without the need to rewrite everything. One thing before I hand over to Reza to talk about the MongoDB example that I wanted to make sure you understand is the attribute tree and the metadata we provide. So in general, in Chef, there are different sources of Chef attributes. There is the underlying OHI layer that Chef discovers about the instance itself, like what instance are you running, what packages are installed, how much memory does the box have. Then there are the cookbooks, which provides default attributes. And then there are like 3 things that are special to OpsWorks. One is the deployment JSON, so you can like override JSON per deployment, so like set a specific revision for this deployment or change a specific value just for this deployment. There is the stack configuration JSON, like the built-in values that OpsWorks provide, and we will dig in a second into that. And then there is the custom JSON that we had a look at earlier that allows you to do any arbitrary random JSON that you would like, and that will like influence all the others and win over those. Apart from the low-level OHI values that you can't change because you like cannot override them how much memory you have, unfortunately. So that stack configuration JSON is interesting because this is how OpsWorks communicates the information about the stacks to your system. There are several sources to that. So they are all under the node OpsWorks tree. So there is information about the layers, like which layers are in the system. Like this is how the load balancer finds out that there are new application servers, because it says, I want to have the IPs of all the servers in the layer Rails application server or Java application server, for example. There is the instance tree that gives you information about the instance you're currently running on, like in which layers, or which layers is this instance part of, which AZ is it in, which VPC, maybe which subnet, what type is it, and all of those information that you would expect. And then there is the information about the stack itself, like what is the name of the stack, what applications are deployed onto the stack, and so on. And apart from those, for those things, there's also, of course, the cookbook and the layer-specific attributes that you can look into. And we're going to see later how we use that in order to like auto-discover other nodes, how like the MongoDB nodes will discover where the other replica pairs are, and so on. And we're also going to revisit that when I talk at the end a little bit of what are the differences between Chef Server and OpsWorks. But it's very, very like important to remember, okay, we have that special data structure that you can look into and discover all the nodes. There's also on every machine a simple CLI tool that will give you, that will basically print out this information so that in every box you can look into it and see, okay, what is actually there and what is available. And yeah, with that, I hand over to Reza, who will talk about MongoDB.
Thank you, Jonathan. Hi, everybody. So we are gonna talk about a concrete example now. We have seen the theory. We have seen the lifecycle event framework. We have seen the several customization possibilities that OpsWorks gives you. And we have seen the metadata that OpsWorks delivers to the instances and to the Chef recipes. OK. Some of you may know that OpsWorks offers, of course, I mean, some of you may have already used some of our built-in layers, right? Some may have even created their own custom layers. What I'm going to do in the next 10 minutes with you is show you how easy it is actually to create a custom layer. Say for software that is built by your organization, in case our deployment types are not fitting your needs, you can create your own types. For software, for open source software that your organization is running, you can leverage the hundreds of open source community cookbooks that are present in the chef community. All right, enough said. Let's have a look at the example that we're going to use to understand these principles. Here we have, we're going to build a stack which is composed by 3 layers. And it's going to run a MongoDB replica set. We're going to have an elastic load balancing layer using OpsWorks integrated support for AWS Elastic Load Balancer. We're going to use a Java application server layer using the built-in Java layer that we have launched just recently. And we're going to extend that, and we'll see in a second how. And we're going to create our own custom layer, as said. Custom layer that is going to run a MongoDB replica set. Now, to make sure that we are all on the same page, just let me spend 2 words on what is a MongoDB replica set. MongoDB replica set is a cluster of MongoDB nodes which act as a single MongoDB database. And they have the possibility of failing over dynamically. And they elect, the nodes in the cluster, participating in the cluster, are capable of electing a new master whenever the old master is failing. The master is going to receive your write operations. And the other nodes, optionally, can receive read operations from the clients. In this case, from the applications, from the Java applications running on the boxes of our Java application server layer. So let's recap for a second on the objectives that we want to achieve with this example. We want to run MongoDB as a custom layer. We want to use the Chef community cookbook for MongoDB. We're going to extend the Java application layer because we want our Java applications to be aware of all the nodes that are composing the replica set. This is important because a MongoDB client needs to know about all the members of the replica set before, say, to interact with it properly. And then we want to manage the system lifecycle, which means for us we want to take advantage of the features that OpsWorks give us, and we want to, take advantage of things like auto-scaling or auto-healing, and indeed achieve a great operational experience. OK, let's dig in how we're going to build a MongoDB custom layer. We start with the community cookbook. We can see the URL on the slide. All right. And again, the chef community has a catalog of hundreds of community cookbooks. We're going to leverage the functionality that is already present in the cookbook. OK, so we are interested into installing MongoDB. We are interested into having the MongoDB nodes register with their peers to form this replica set. We want to have, of course, management of the service startup and management of the shutdown of the nodes in a clean way. OK. So what we're going to do with this community cookbook? The cookbook is a collection of recipes where you can think, if you don't know chef before this talk, you can think of the recipes as automation scripts, all right, written in Ruby. We're going to leverage the the lifecycle framework that we've seen before. And we're going to start taking the cookbook recipes, and we're going to bind them to the different lifecycle events that we have available. This is quite easy through our UI. And let's see that. We're going to bind 2 recipes to the setup event and 1 recipe to the configure event. Those recipes are going to be executed in the order in which we add them. This is important for our setup event, and let me tell you why. The first recipe is the MongoDB 10gen repo. This is going to take care of actually setting up the package repositories for MongoDB, the official ones, so that we can install the latest stable version. Of course, we could also choose with further customization which exit version we wanna install. This will run before the MongoDB default recipe, which will take care of doing the basic setup as we have put it in the setup event. This means we're going to install MongoDB, and this means we're going to also create the initialization scripts, the init scripts to manage service startup and shutdown. OK, now the most important recipe of our example is going to be the MongoDB replica set recipe that we're going to tie to we're going to bind to the configure event. This is important, and as we've seen before, whenever an instance in OpsWorks enters the online state or leaves the online state, OpsWorks will send a configure event to all the instances across the stack. In our case, we want all the nodes in the MongoDB layer to actually run, to actually say, become aware of new nodes in their same layer that become available or that are shutting down, okay? Because they must know about their peers. How we're going to do this? Say, how we're going to actually leverage this MongoDB replica set recipe? The point is that the replica set recipe that is present in the official community cookbook for MongoDB leverages a peculiarity, a functionality of Chef Server, which is called Chef Search. Now, as Jonathan told us before, and he's going to actually show us and talk about this a bit more later, Chef Search is not available in OpsWorks, okay? But OpsWorks, that is running a standalone flavor of Chef, which is called Chef Solo, provides the recipes with a rich set of metadata. To leverage that metadata, we're going to then apply a simple change to our recipe. And this, in essence, is the core of this change, okay? There is a couple of lines more that we're not going to show now because they're not meaningful. What we are doing here, we are simply walking the OpsWorks attribute tree, and we're going to see that we are collecting all instances that are present in our layer, in our replica set layer, and we are going to build a collection. We're building a collection of Chef nodes, which are representing the nodes, the MongoDB nodes, and we're going to return that to the existing replica set recipe of the MongoDB cookbook. Just that. That's all I had to do to enable my stack to use a replica set. We're going to do also some more configuration, okay, some more customization. And we're going to leverage the custom chef JSON that OpsWorks let us bind to a stack. In this particular case, we are going to set two values in the MongoDB namespace. The MongoDB namespace is already used by the Chef MongoDB community cookbook. And to pass this data to its recipes, we don't have to do any change to the community cookbook. We're setting two values, as you can see in the example. One value is going to be the replica set name, which we're going to set to the name of the layer, to the short name of the layer in which we host our MongoDB replica set nodes. And the other value is the DB path. We're going to tell our MongoDB default recipe, hey, I want my MongoDB database to live on disk at that path, in this case, vol data. As a bonus, because we have the possibility of doing this, we're going to actually also take advantage of OpsWorks support for EBS. And it's utterly simple to change the layer settings of our MongoDB custom layer and tell OpsWorks that for each of the instances, every instance that runs in the layer, should have an additional EBS setup mounted at the mount point of all data, the same one that we are passing down to our chef recipes. And we select one of the rate configurations that we support, the number of disks, the size in gigabytes, and we're done. Every time an OpsWorks instance is gonna boot, the OpsWorks instance agent will take care of setting this up for us. OK, that's all we had to do to actually set up MongoDB custom layer. Not much, right? We're going to now quickly go through the changes that we need to actually extend the built-in Java application layer. As we said before, we want our Java application servers to be aware of the MongoDB replica set nodes. They must know all of them because they have to treat them as a whole. All right. For doing that, we're going to inspect what OpsWorks built-in Java layer is doing for us. OK. And for doing that, we can simply open the layer Java App Server, have a look at the built-in chef recipes, and see the recipes that are used. We notice that there is an OpsWorks Java configure recipe used in the configure event. Well, that's the right event, right? Every time there is a change in our stack, every time a MongoDB node comes up or goes down, we want to tell our Java application servers. So, but how to leverage this the most simple way? We can use another approach that Jonathan told us before, which is simply overriding the chef templates that come with the OpsWorks Java cookbook. You can see the template itself. So the OpsWorks Java configure recipe is setting up the web application context normally, and is doing it using this template. What we're doing here is throwing away the built-in template and putting in place our own. And we're going to walk again through the metadata, through the OpsWorks attribute tree. We're going to build a list of MongoDB nodes. And we're going to pass that list of MongoDB nodes, for instance, in an environment variable in the web application context. Of course, this is a very simple approach. And in production, depending on your technology stack and so on, you're going to use very different approach. But the principle is the same. OK. All right. We're basically done. We just need to do one more thing, and we are ready to actually run our stack. We have to package our custom cookbook. To package it, we're just going to build a tarball or an archive. And we're going to have this, what we can call compound cookbook, or anyhow, a cookbook archive. We're going to put the Chef MongoDB community cookbook there with our little addition that we've seen before, with our little change. We're going to put the OpsWorks Java addition that we have just seen. OK, so just simply the template file. And then we're going to put the dependencies of the Chef MongoDB cookbook. By dependencies, I mean other cookbooks that the Chef MongoDB cookbook is actually using. Once this is done, we package all of it. And we tell OpsWorks, using one of the options we've seen before, S3, HTTP, source code repos like Git or SVN in an authenticated fashion or not, to actually say where the OpsWorks instances will be able to download our custom cookbook. All right. OpsWorks instances, when coming up, will be able to download that. We'll extract the contents of this file, and we'll be able to use the cookbooks that we have packaged. And that's it. We're done. In under, say, if we wait 5 more minutes after pressing start all instances in our OpsWorks UI, we're going to achieve this, having our stack completely running. Thanks.
So we're not fully done yet. I promised you a third part. The third part is, what are the differences between Chef and OpsWorks and Chef Server, like the open source edition or hosted Chef? We're going to talk about how the setup differs. Also, we already saw a couple of the things, like the discrete runs or events that you have in OpsWorks versus like the one continuous run that you have in Chef Server. We're going to talk about push versus pull briefly, and the two biggest things are probably search and data bags. Those are the most common questions that we hear. So first, just a quick reminder what the difference is if you have a typical Chef Server setup and if you have OpsWorks. So in OpsWorks, we have Chef Solo, and we don't have a Chef Server. So we have our own custom backend that uses that triggers those events and then starts Chef Solo whenever that event starts. In a typical Chef Server setup, you have Chef Client, which is basically just Chef Solo plus it calls back to Chef Server every now and then. And you have Chef Server, which provides similar capabilities to OpsWorks, but the couple of things where it differs are, on the one hand, the lifecycle events. Hopefully by now you understand that you have those distinct events that fire whenever something happens, like you boot a new machine, you shut it down, a machine crashes and gets replaced. The advantage is they're way faster to execute, so you don't have like one big chef run where you do everything. You can tell us that we know this is the configure step, so I don't have to check if Apache is actually installed. I just have to render the database config file again. And that gives you also context to know, because you can like list, you don't have to make your recipes like fully aware of everything that is happening, because you can say this recipe will always only run on shutdown. I don't have to care about those other things. The other big difference is the push versus pull model, where in a Chef Server setup, you typically have, for example, the client run as a cron job or run continuously, pulling every 15, maybe, I think the default, I'm not sure if it still is, but it used to be like 30 minutes or something from the server, which means it's not, usually you don't do deployments via that, for example, because you don't want like, I change the config file that says what the latest version is, and then I wait half an hour for all my fleets to pick it up, right? You want to push it now to those 5 servers, see, and immediately see the result. In Chefland, you sometimes then use Knife for doing similar things, but in OpsWorks, we have that push model where if you do a deployment, it's immediately pushed to all the machines, and you can specify all of your machines in a stack. You can specify a certain layer or just individual machines, so you can say, deploy this to one of my servers, the new version, and then I like observe, I do like a kind of a one-box testing and see if this machine has now a higher error rate than others, and only when I'm happy I'm pushing it to all of them. That also gives us a possibility to immediately respond to changes. So in that model where you only apply the config changes every half an hour, it takes you, like in worst case, 29 minutes to know that this database server is no longer there, where in OpsWorks it's immediate. So this is where those models differ a little bit. Probably the biggest change to what if you take a community cookbooks and what we saw in the MongoDB example, what we had to do is how do I do discovery? How do I find out where the nodes are? Chef provides you the search function. OpsWorks does it differently. So you can achieve the same means. So we saw how we could discover where are all my my MongoDB nodes, but we didn't use search for that. Instead, we relied on the node OpsWorks data structure that lists me the metadata about my system. It's kind of similar to partial search, if you know that feature from Chef Server. What we're going to do in the future, we want to align this. So this is today is a thing where you have to be a little bit careful. If you use a community cookbook that uses search, you have to change 1 or 2 lines to do this query method. And this is something that we don't like because we want the experience to be seamless for you. So we're going to work on making that difference go away. But today it's important to know that it exists and how you use that. So a typical use for search is like I want to have the list of all servers that are in the web role, how we would say in Chef Server, which is like the web layer in OpsWorks. How we can do that, we already saw that in the MongoDB example, but just again a reminder. I query the OpsWorks layers data structure that lists me all the layers that are in my stack and all the instances that are in there. So in this case, I'm interested in the IPs of my Rails app layer servers. So I find out, okay, what instances are in that layer, and then I iterate over them and grab just the private IP part And this is how I can then populate a template that has them listed somewhere, or do then whatever I would do that later on. So those first 2 lines would look differently if you use search, but the output is the same. So at the end, you get the list of IPs of your Rails app servers, and that's what you care about. What you can't do this way is find out dynamic information that is present only in one node is provided by attribute data. So like if you write a dynamic attribute value in just in one node that is not like coming from OpsWorks, but you generate on one server, you can't find it out this way because that data structure only has information that OpsWorks has and pushes down to the machines. So if you generate something locally, it will not be present in that data structure. But for the vast majority of use cases where you care about discovery, you can easily do it this way. The other big question that people who are familiar with Chef ask is, what about data bags or encrypted data bags? Right? So like, how do I achieve and again, the answer is, well, you can easily reach the same goal. The means are slightly different. And again, this is something that we will try in the future to make easier and like that difference go away. And just like give you the same interface, but under the hood we will implement it using the way that I'm going to describe to you. So encrypted data bags, there are 2 ways to do it. Like this, the first way is to do data bags. One way how we already saw to do it is just using custom JSON. So I can use on the stack or on the deployment, I can put any arbitrary JSON. So if my goal is I have like a secret in my that I don't want to put in my cookbook, because my cookbook is in source control, like I have 10 freelancers who have access to that. I don't want to give them the password to connect to the payment server. You could put it in the custom JSON and just reference it by an attribute value. OpsWorks itself stores it in encrypted fashion, but you would have it in clear text in that box, so maybe that's not good enough for you. So the next step, what you could do is you could store secrets on S3. So what you could do is you take the JSON file that you have locally, very similar to how you would upload it to Chef server on a Chef server setup. You encrypt it locally, and then you upload it to S3. You put it in a private bucket, and then you use IAM instance profiles, so instance roles, to grant your instances access to that file on S3, so they can download it from within a recipe, and then this way access the encrypted secret. So you can, in that sense, the same way, like transport secrets to the machines, not have them in your cookbooks. This is a little bit more verbose than data bags, but hopefully we will soon be able to announce that you no longer have to do this and can just use the data bags and the search APIs. But the important thing is you can actually do the same things. You may just have to change 1 or 2 lines in your cookbooks. So with that, hopefully we gave you a good overview about how OpsWorks works under the hood. What is like for me the most important thing that hopefully you took away is that lifecycle framework, to really understand how and when the different events fire, what the difference is and where I can use it. And that in its heart, like OpsWorks is a lifecycle automation framework where we happen to tie in Chef in order to do the things. But it's not limited to that, and you're not limited to the built-in layers. Like, it's highly customizable. Anything that is scriptable, you can run on OpsWorks. Anything that you can trigger with a Chef run, that you can trigger with a bash script, you can make run on OpsWorks. So we have customers running anything from Erlang to Clojure to Scala to Python to anything that is basically you can script and automate on machines. If you want to know more about OpsWorks, and if you, for example, want to have the source code to the examples we showed, make sure to go to the OpsWorks lab. You can test and try out OpsWorks there. You can find out later at the booth. There's always somebody from OpsWorks there, so you can ask any detailed questions. We have a Twitter account. We have some presentations on YouTube and tutorials. We recently launched an application management blog together with the CloudFormation and Beanstalk guys, where we're going to post the source code and the examples and a tutorial how to do the Java and custom MongoDB layer example. And there is also a survey if you want to give us feedback, what features you would like to see, anything that you think is missing or is, like we could improve, feel free to fill that out. We're very happy and eager for customer feedback. And the last thing that I have is just to remind you that right after this session in the same room, Intuit is going to talk about how they leverage OpsWorks to build their own platform as a service solution. So if you're interested to hear more about OpsWorks, about how other companies are using it, just stay here. Otherwise, we would be open for questions. And I think we have about like 5 minutes for questions.